Welcome back to the channel, guys. Hope you are doing extremely well, and this is your very own mascot on this side. Welcome to the English lecture number 22. Okay, so the question for the day is add two numbers represented as linked list. What does the question state? That suppose you have two numbers. Suppose one of the number is 4 connected to 5 connected to 6. This linked list is actually representing a number 456. And suppose the second number is 323. This linked list is representing the number 323. So if I add them up, 6 plus 3 gives me 9, 5 plus 2 gives me 7, and 4 plus 3 gives me 7, right? So I will have to return a linked list which looks something like this: 7, 7, 9. 7, 7, 9 is my output. So these are my input and these are my output. Now, I would like to request every one of you, if you have not visited the video for add one to a linked list, add one to a linked list, which is just the previous lecture, that is lecture number 21 of the linked list series. Please go and check that out. Please go and check that out, because if you understand that video, this video is going to be a cakewalk for you. You will be able to understand what I am trying to say. Okay, so I am sure that you have watched this video and you have been familiar with the input and output scheme. Now, how to proceed? How to proceed? As I discussed in the add one to a linked list, there is a hack here also. What is the hack? Hack says calculate long num1 and long num2. That is, make two integers long types and just start traversal. That is, convert this linked list into the number 456, convert this number into the 323, and now carry the sum forward and then fill the linked list with 779. What I'm saying is, I'm saying suppose my temp equals to list 1, my temp equals to list 1. What will happen now? I will say while my temp num1 was initialized by 0 first, so num1 becomes num1 star 10 plus temp data, right? And then temp moves next temp equals to temp next, right? And moving forward. Similarly, calculate num2 from list 2, and then you can do num1 plus num2. Let us store in it value, right? And now make a new linked list to insert this number into the linked list, right? So I hope that is clear to you. But this is a hack. This is not the approach that interviewer would like to see from you, right? Now, but there is still a problem with this hack. What is the hack? Suppose it has been given to you that the linked list size can be around 10 to the power 10 nodes. If the linked list says that the linked list size can be to around 10 to the power 10 nodes, that means maximum value can be 9, 9, 9, 9, and this 9 will occur 10 to the power 10 times. Are you able to visualize that? 10 to the power 10 times. So that is a very big number, right? That is a very big number, and no integer data type or no long data type can hold such a big number, right? That will be a problem for you. And then you have to carry the addition also. So you will have to go through the linked list approach for the bigger test cases as well. Okay. So suppose my linked list is the same: 4, 5, 6, and 3 to 3. 4, 5, 6, and 3 to 3. 4, 5, 6, 3 to 3. Right? How will I solve it? So I would like to go into the secondary school, and I will see how do I carry additions and subtractions and etc. there. So 4, 5, 6, 3, 2, 3. How did I do? So I started from here. I started from the lowest bit. I started on the rightmost start, right? First pointer. So 6 plus 3 gives me 9. I can say the carry here is 0, 0, 0 right now. 6 plus 3 equals to 9. 5 plus 2 equals to 7. It is actually 5 plus 2 plus 0. That is the carry. 6 plus 3 plus 0, right? 4 plus 3 plus 0 gives me 7, right? This is the linked list. So what is my flow? I am going right to left. I am going right to left. This is my second pointer. Now, I will try to include that into my this approach. What will happen? I have got 4, 5, 6 and 3 to 3. Now I saw that I have to go in this direction. But in the linked list, the direction that is feasible to me is this direction. That is a problem for me. That is a problem for me because in the linked list native way of going, 4 comes first, then 5, then 6. Similarly, 3 comes first, then 2, then 3. Right? So what do I do? What do I do? I can actually reverse both the linked list. I can actually reverse both the linked list. So after reversing, the linked list looks something like 6, 5, 4, and 3, 2, 3, right? The first linked list becomes reverse 6, 5, 4, 3, 2, 3. My L1 is here, my L2 is here. Now you can see 6, 3, 5, 2, 4, 3. 6, 3, 5, 2, 4, 3. The flow I wanted is ready with me. The flow I wanted is ready with me, and now I just have to deal with it. Now what will I do? I will just carry out my normal approach. I will just create a dummy node. Let us say this is my dummy node, and I will keep A here. My L1 and L2 are here. My L1 and L2 are here. Now what will I do? I will say value equals to L1 value plus L2 value plus carry. Carry will be initialized by 0. Carry will be initialized by 0. Suppose this is my carry, which is initialized by 0. Value will be annual value, that is 6 plus 3 plus carry is 9. Okay. Now suppose I change this value 5 to 8, right? To introduce the carry concept of carry only, right? 6 plus 3 gives me 9. So what will I do? I will create a new node, that is A. I will keep it here. A is next equals to new node of the same value, new node of the same value, that is I will attach this to 9. After that, A equals to A next, further traversal, A equals to A next. So A comes here. Now the work for these nodes 6 and 3 actually finished, so I can delete them to free the memory. I will delete them. These nodes have been deleted, right? If you're following the playlist, you know how to delete it, right? L1 comes here, L2 comes here. A equals to A next, L1 equals to L1 next, L2 equals to L2 next, right? And now delete the nodes, that is delete previous of, I will not mention it, I will just do it in the code itself. Delete the nodes, right? Delete L1 and L2 previous node, delete L1 and L2 previous nodes, right? Now your A is here, no problem. Now moving on, L1 plus L2 plus carry. My carry is 0 right now. 8 plus 2 equals to 10. So value will become equals to 10. Value will become equals to 10. Now you know that the linked list node can get the value of maximum 9, right? It should be in the range 0 to 9. That is a condition, right? It should be in the range 0 to 9. It is representing 10. How will I solve it? So whenever there is a number which is greater than 9, what do? We create a concept of carry. Now I want 1 as my carry, and I want 0 to be stored in the number. 10 percentile 10 will give me 0. 10 by 1 will give me 1. That is, I will say carry equals to A's data, because A has already been transferred. A equals to A data, and now A data percentile equals to 10. That is, 9 will insert 0 in front, A will move here, and my carry now is 1. Moving forward, carry here is 1, L1 is here, L2 is here. These nodes have been deleted. So let me rub them down. Right now, my value will be 4 plus 3 plus 1. That is 4 plus 3 plus 1, which is equals to 8. So I will create a new node 8. I will create a new node 8 here, right? And my A will move here. And now you can see L1 is null, L2 is null, my carry is 0, right? This is the simplest case. L1 becomes null, L2 becomes null, carry is 0, right? And I have got the linked list as -1 908, -1 908. What will I do? I will delete the dummy node. My head will be placed here. So my linked list is 908. But there is still a problem. I actually reverse the linked list. So I will have to reverse it again. This number will look something like 809, which is my actual answer. Now the problem with this is that this case is simple. This was the simplest case we discussed above. Simplest case. Things that can occur is, first of all, it has been mentioned in the question that the linked list, the numbers represented by linked list, can have leading zeros, but there should be no leading zero in the output, right? Second of all, L1 and L2 length can be different. L1 and L2 length can be different. Third pointer is, carry can be remained after the addition. Carry can still be non-zero after addition. Let us try to fix all these problems one by one. So first of all, this one can have leading zero. What will I do? So suppose the number is 0809. This is actually 809, but because of the leading zero, the linked list is actually looking like 0809, right? So what will I do? My L1 is here. Now what will I do? I will keep traversing L1 until I found a non-zero value. So my linked list will look something like while L1 next. Why L1 next and why not L1? Because it might be possible that linked list is 0000. In that case, I want my L1 to be 0. I want my L1 to be 0. That means I will have to stop here. I don't have to delete this node. So while L1 next and L1 value equal to 0, what will you do? You will say x equals to L1, L1 equals to L1 next, and now you can delete next. You can delete x. So delete x, right? In that case, this number will get deleted and you will keep your L1 at, your L1 will be placed here, 809. Now, moving forward, I will do the same for L2, same for L2, same for L2. Now you can see the first pointer is clear, the L leading 0 will be removed. Moving on, L1 and L2 length can be different. L1 and L2 length can be different. How will we tackle that? That means 809 with 5, 4, 5, 6. What will happen? I will reverse it. So 9, 0, 8, 6, 5, 4, 5. I will carry out the addition. You can see 9 should be added with 6. 9 is getting added with 6. 0 should be added with 5. 0 is getting added with 5. 8 should be getting added with 4. 8 is getting added by 4. 9 plus 6 gives me 15. So it will store 5 here. It will store 5 here. 1 will move here. It will go 6. So it will remain 6. 8 plus 4 gives me 12. So 2, 1 and 1 will go here. 1 plus 5 gives me 6. So it will actually get changed to 6. So 5, it is 2 here. So 5, 6, 2, 6. 6, 2, I will reverse it. So it will become 6, 2, 6, 5, which is my linked list, right? So what will I do? After the length which has been finished, if any L1 or L2 persists, I will carry out the operation for that only. So after the loop of L1 and L2 finishes, L1 and L2 finishes, for safety, do the loop only for L1 and only for L2. One after the other, only for L1, then only for L2, right? This will solve the second problem. This will solve the second problem. Third problem is, suppose the linked list is 9, 9, 9, and you are adding 8 to it. You are adding 8 to it, right? So after reversal, the linked list will remain same only, so I am not writing the reverse order. 8 plus 9 gives me 17. 8 plus 9 gives me 17. I will store 7 here. I will move with 1 here. 1 plus 9 gives me 10. 0 comes here and 1 comes here. 1 plus 9 gives me 10. 0 comes here, 1 comes here. Now because 1 comes here, I will have to add a node here, right, of value 1. Right, I will have to add a node. So what will I do? A is already here, so I will just say while carry. What will you do while carry is there? A next equals to new node of the value carry, and then you can just simply carry A equals to A next, A equals to A next, and carry equals to A data percent by 10, and A data equals to percentile equals to 10, right? This is the simplest operation you have to do. At the last, you will get the answer, you will get the playlist with the dummy node, you will have to delete the dummy node, and you will have to just reverse the linked list, right? So I hope that is clear to you. Let us give a dry run to a difficult example which is covering all the edge cases. So for example, my edge case is 4, 5, 4, 9, and you are adding 800 something like 809 to it, suppose, right? And here it is a 0, here it is a 0. So my first will be to remove the leading 0. That is, first my L1 was here, my L2 was here, my L2 was here. Now I will remove them. So L1 does not remain here, L2 does not remain here, and they both move forward. L1 comes here, L2 comes here, right? Now what will I do? I will create a dummy node. I will create a dummy node -1. This is my dummy node. My A will be placed here. My loop will start working while L1 and L2, that is, they are both going hand in hand. So 4 plus 8, my initially carry is 0. My initially carry is 0. 4 plus 8 plus 0 gives me 12. 12 by 10 gives me 1, which is my carry, and 12% L2 will give me 2. So it will be 2 here. A will come here. Now I will move L1 here, L2 here, delete the previous nodes, right? 2 will come here and carry will get changed to 1. Moving forward, 5 plus 0 plus 1 gives me 6. Carry becomes 0 and it will remain 6. So 5 plus it will get connected to 6. It will get connected to 6. Moving on, A comes here and then I will delete the node. So L1 and L2 comes here, L1 here, L2 here. 9 plus 4 gives me 13. 9 plus 4 gives me 13. So carry is 1, 3 comes here. So I will attach a node of 3. A will come here, carry again changes to 1, which was initially 0, right? Carry again changes to 1, and now my link, these both the pointers are getting deleted, and now L1 comes here and L2 is at null. Because L2 is at null, this loop is getting terminated. I will have to go for L1 only, while L1 is not null. So I will just add 9 plus 1, because 1 was my carry. I will add 9 plus 1. So 9 plus 1 gives me 10. 1 carry, 0 value. So 0 comes here, A comes here. Now you can see L1 also goes to null. L1 also goes to null. So I will use only carry. While my carry is there, I will just add a node here. And now my linked list is 26301. I will just reverse it. It will come 1 0 3 6 2. Right? This will be my dry run. So I hope you are able to understand it. And now it's time for you to see the code. Alright guys, so here is the coding section. I have just pasted the code for reverse, as you can see. If you do not know how to reverse a linked list, please follow the playlist. There has been a video on the reverse of the linked list. Please follow that. Now moving on, add to list. Before starting with the code, I would like to request you to please subscribe to my channel because it helps me a lot, right? It helps me a lot. Now moving on, add to list. What will I do? First was to remove the leading zeros. So while L1 next is not null and L1 value, L1 data, sorry, because it is GFG, is equal to 0. What will I do? L1, I will just delete the node. So list node, node star X equals to L1. L1 move forward, that is L1 equals to L1 next. And now I can simply delete X and free the memory. So delete X. Moving on, same for L2. Same for L2. So I will just say it is L2 here, L2 here, L2 here, and L2 here, as well as L2 here. Moving on, what will I do? I will just reverse them. So L1 equals to reverse of L1 and L2 equals to reverse of L2. Moving on, I will create a new node. So node star dummy equals to new node, which is having a value of -1 currently. Similarly, node star A equals to dummy for easy addition and traversal. Now, first loop run, I will have to create a carry also. So int carry equals to 0. Now, first loop run while L1 is not null and my L2 is not null. In that case, my value will be equals to L1 data plus equals to L2 data plus equals to carry. I will just insert it. So A is next equals to new node of value A equals to A next, A equals to A next. Now carry equals to A next by 10, carry equals to A next by 10, and A data sorry, carry equals to A data by 10, and A data becomes percentile of itself. Right? Now I will have to delete the L1 and L2 to free the memory. So list node star X equals to L1, L1 equals to L1 next, delete X. Similarly, X equals to L2 now, L2 equals to L2 next, and delete X. This will give me the linked list for the what do we say, for the L1 and L2 are not null. Now separately, while L1 is not null, I will do the same operation. So I'm just copy pasting it, just few changes. It will not be L2 data anymore, right? It will not be L2 data. Similarly for L2, so I control C and control V. What will I do? I will say L2, it is L2 here, value becomes L2 data plus carry, and everything remains same, only this will get changed. L2 here, L2 here, L2 here. Now the last case for carry. So while carry, what will happen? A is next equals to a new node of value carry, A equals to A next, and now carry becomes A data by 10 and A data percentile equals to 10, percentile equals to 10, and now it is sorted. After that I can just remove the dummy node. So list, node star head equals to next of dummy, dummy next, delete your dummy to free the memory of the -1 node, which is not at all useful now, and just return the reverse linked list. So reverse of head. Right? It should run fine. Let us try to compile and run it. Hope it will work fine. I just added the extra space for better visualization on the screen, so I'm removing it. And it is running. taking a lot of time. GFG takes a lot of time. That is the problem with GFG. Alright, so it is running fine for the compile and run. Let us try for submit as well. In the meantime, do consider subscribing to my channel if you're new here and if you found the video at all useful. Okay, so you can see all the test cases are getting passed because the code is correct. So hope you like the video and thank you for watching. Meet you in the next lecture. Till then, stay safe and keep coding. Okay, have a nice day.